Welcome to my 53rd tutoring session in A-level chemistry. In this video, I'll explain how to calculate the relative atomic weight of an element. Don't forget to subscribe my channel, share, like, comment and watch the full video. So how do you calculate the relative atomic weight of an element? Let me explain with respect to the carbon element. Atomic number of carbon is 6 and it represents the total number of protons present in the nucleus of carbon atom. Mass number of carbon is 12 and it represents the sum of the protons and neutrons present in the nucleus of carbon atom. Naturally occurring carbon contains three isotopes: C12, C13 and C14. Isotopes of an element have the same atomic number but different mass numbers. The three isotopes of carbon are C12, C13 and C14, where you find the same atomic numbers but different mass numbers. So atomic number is same, that is 6, while you find varying number of mass numbers, that is 12, 13 and 14. Now what you see in the periodic table is the relative atomic weight of carbon mentioned in decimals and not as whole numbers. So why do you find the relative atomic weight of element in decimals and not as whole numbers? Let's find out. One should be familiar with the three important terminologies in order to better understand the concept of relative atomic weight. They are atomic number, mass number and relative atomic weight. Atomic number represents the total number of protons and it is 6 in case of carbon. And mass number represents the sum of protons and neutrons present in the nucleus and it is 12 in case of carbon. And relative atomic weight of an element is the average atomic mass of its naturally occurring isotopes. And what are the naturally occurring isotopes in case of carbon? They are C12, C13 and C14. So let's examine the nucleus of these three isotopes of carbon. The nucleus of C12 isotope contains 6 protons and 6 neutrons and hence the mass number is 12. The nucleus of C13 isotope contains 6 protons and 7 neutrons and hence the mass number 13. The nucleus of C14 isotope contains 6 protons and 8 neutrons and hence the mass number 14. The relative abundance of carbon 12 isotope is 98.89%. The relative abundance of carbon 13 is very low with a value of 1.1%, while the relative abundance of carbon 14 is very negligible and is around 0.01%. Remember, here the numbers 12, 13 and 14 represent the mass of the respective isotopes of carbon. And how do you calculate the relative atomic weight of carbon? You simply multiply the mass of each isotope with its relative abundance and then sum up all the three values and divide the whole thing by 100, because we are mentioning the relative abundance of these isotopes in percentages. Therefore, you divide the whole thing by 100 and that is how you get the decimal value of 12.011 for carbon. That is, the relative atomic weight of carbon is 12.011. The relative atomic weight of an element is the average atomic mass of its naturally occurring isotopes, and that is why you find the relative atomic weight of elements in decimals and not as whole numbers. Thank you so much for watching my video. I hope you enjoyed it and I'll meet you in my next interesting tutoring session.